Okay, so we've talked about motion in exercise 1 and EMG recording in exercise 2. So in exercise 3, we're going to combine them together. We're going to see what EMG looks like during gait. So this is something similar to the lab setting described in our manual. A man has a harness on him, and it can unload his body weight during walking. So there are two scenarios. The first one, in the first column, is a normal body weight load during walking. And the EMG is recorded on gastrocnemius and tibialis anterior. So it's basically the plantar flexor and dorsiflexor. And in the second scenario, the harness unload 50% of body weight. And we also recorded gastrocnemius and tibialis anterior to see what's the difference between a lighter body weight and normal body weight. And before we talk about this graph, we can talk about gait first. I'm not sure if you've had a clear concept of all the gait cycles, but for gait cycle, we can easily divide into two phases for each limb. So if we're talking about gait cycle, we're only focusing on one limb. And here we're looking at this one, which has a dark color. And the first step we can divide into two phases, which is stance phase and swing phase. So you can see in stance phase, the leg is contact with the floor throughout the whole phase, right? So it's here, 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 and here. And swing phase, the leg is swinging in the air. It's not contacting with the floor. And then we can divide those phases into more detailed phases. So in stance phase, initially you need an initial contact with your heel to the ground. And then you're going to transit your body weight onto this limb. And in these two phases, both legs are on the floor, so it's also called double support phase. And then when your body weight is fully loaded onto the stance leg, your another leg will lift off. And then in the terminal stance and pre-swing, your leg is trying to provide a propulsive force to generate an anterior force to make you progression to another step. And in swing phase, your leg is in the air, and so in the terminal swing phase, you're going to transit into stance phase. And what's separating these two phases is a toe off of your limb. So from here, if your toe is lifted off from the ground, that's transit into swing phase. And then we can look at EMG. What does EMG looks like during the gait cycle? So it's initial contact and to swing phase here, toe off swing phase. So we can see, we can take a look at gastrocnemius first. It's activated in mid-stance, terminal stance, and pre-swing. That makes sense, right? Because in stance phase, it provides vertical force to support our body weight. And also in pre-swing phase, it provides propulsive force to push our body forward. And when we take a look at tibialis anterior, in swing phase, it's trying to bring our forefoot up in the air. So it's providing a clearance from the ground, right? It's supporting the mass of your foot. So it's activated in the swing phase. But in loading in the initial contact, why is it also activated? That's counterintuitive, right? But we can take a closer look at detail of ankle joint. So think about torque. If the axis of rotation is here at the heel, and there are two forces during initial contact. The first is your body weight, right? And if there's only body weight, they'll generate a clockwise torque, right? And bring your foot clockwisely. But imagine there's no other forces, then you're going to do a slap gait. You're slapping your foot on the ground. But we don't want to slap it, so we have another force generated by tibialis anterior, which is providing a braking force to make your foot segment slowing down before slamming to the floor. Okay, does that make sense? That's kind of, it take a second to think about it. And then until pre-swing, because you want to bring your foot segment up, right? So to facilitate the floor clearance, so your tibialis anterior is activated in a swing phase. Okay, so here is an example of myself collecting myself walking, and we got gastrocnemius here and tibialis anterior here. And when I play the video, you can see it alternates, right? So you can take a closer look. Again, you can see gastrocnemius activates, and then TA, gastroc, TA, gastroc, TA. So it's alternating pretty well, and we call it a phasic activation compared to co-activation. So phasic activation means they're doing it alternatively. So that's the answer for the first question in exercise 3, that when were the gastra and tibialis anterior active during the normal body loading condition. So you can see in this graph, when TA activates, there's no activation at gastrocnemius, right? And when gastrocnemius is activated, there's no activation in TA. So it's not co-activation, it's phasic activation. They take turns. And that's the answer for question 1. They're demonstrating phasic activation. Okay, and for question 2, use yourself as a model to determine the function roles of these two muscles during gait for both stance and swing phase. So we can think about gastrocnemius first. What's gastrocnemius function during stance phase? Vertically is supporting our body weight, right? And anterior-posterior direction is providing an anterior force to push our body forward and progress into the next step. So it's providing weight bearing and also propulsive force during stance phase. And in swing phase, gastrocnemius is not activated, right? Okay, and for tibialis anterior, in swing phase, it brings our foot segment up, so it doesn't contact with the floor and facilitates ground clearance. That's in swing phase. But tibialis anterior is also activated in initial contact with the floor, right? So it's in initial contact, it slows our foot segment down so it doesn't slam to the floor. So it's supporting the mass of the foot. So that's a function for both gastrocnemius and tibialis anterior in both stance and swing phase. And I'll post this slide on Canvas, so I hope you guys can take a closer look at gait cycle and muscle activation pattern. I think that's a pretty big topic in biomechanics. Okay, so we've talked about question 1 and 2, and I want you guys to discuss about question 3 and 4 based on the knowledge you have. And so the discussion will be the same way as exercise 1. I post the questions on Canvas, and you can just copy these questions and provide your answer in the blank place, and just provide a reply to the discussion. And also, you won't be able to see others' posts before you post your answer. So I hope that facilitate your willing to join the discussion to really want to learn it. Okay, this is kind of a quick lab, but takes some time for like background process of the knowledge. And I hope you guys enjoy the videos. And for the assignment, exercise 1, you just need to complete the table, fill in all the blanks. And exercise 2, you got 3 questions. I think we've covered all of them. And just provide your answer and type the answer. And for exercise 3, we got 4 questions. We've covered 1 and 2 in the video. I want you guys to discuss of 3 and 4 and then put the final answer on the assignment. Okay, that's everything for this week's lab. I hope you guys enjoy and really take action to discuss. Bye bye.